Okay, so the basic concept here behind chapter 10 is that we have two groups and we want to know, are their means the same? For example, we might have male and female athletes and we want to know, do they sleep on average the same number of hours per night? Or we might have two different types of medicine, maybe the standard one that's used already, and then some new experimental medicine, and we want to know, does the time it takes to cure some kind of common cold take the same amount with the medicine that's been in use for a long time or this new medicine that's being used? Whatever the case, you have two groups, two populations, and we want to know, is their mean the same on some variable? Again, we can't get at the entire populations, so we use a mean from each population, and then we look at the differences between those means. Now, even if the population means are the same, their means from the sample are probably not going to be the same, almost certainly not going to be the same. So what we want to know, and what we're doing with this t-test, is what's the difference that we have between the means, and what's the difference that we would expect if the two population means were the same. So that's what this t-statistic is. This top right here, sample statistic minus population parameter, this is saying, what do we have? How far off are we? How close are we to what our goal was? The bottom here, this estimated standard error, is telling us what would we expect to be off. So for example, a t-statistic of 1.0 would be, we are exactly what we would expect to be off because we're taking a sample from the population. We're going to expect to be off a little, and this is exactly what we would expect to be off by. If we get a t of 2.0, we're off twice as much as we would expect to be on average. Twice as much, is that enough to concern us? It kind of depends on how big our sample size. If we're off 3 times as much, 4 times as much, now this is starting to get really suspicious. So in that case, whenever we're into that critical region, whenever we're far enough away off from what we would expect, then we're going to reject the null hypothesis. So that's what this overall, this is more of a theoretical formula. This is a formula in general for t-tests. Now for chapter 10, we're looking at two specific groups. So we have two means, two sample means, two population means, and then the standard error. So again, this top is just saying, how close are we to what we would expect if the two means are the same in the population, and how close would we expect? How close are we? How close would we expect to be? And these two right here, notice population mean 1, population mean 2. These two are going to be the same under the null hypothesis. We're going to say that null hypothesis is saying there's nothing going on. The two means are exactly the same in the population. So this term right here is going to cancel out and go to 0. Because if they are indeed the same, if this is 7 minus 7, 6 minus 6, if they're the same, this is canceling out. And we really just have then the difference between our means and then the standard error of the difference between the two means. And again, we don't have the actual standard deviation, so we're using an estimate here. This is the estimate. Be careful that you don't just add the tops and add the bottoms. Remember to get a common denominator first when you're putting these into the fractions. If the two sample sizes are the same, if n1 and n2 are the same, this is very easy. Then you can just add across. If not, you need to get a common denominator first, or it would be fine to add these in your calculator as long as you add them as separate fractions. Main thing to say about this equation right here is that we're weighting whichever the bigger sample is. So let's say we have two populations. We get 20 students from the first one, 50 students from the second one. We trust whatever we come up with more in that second sample. The higher sample size, this is the law of large numbers, the higher sample size is going to have more valid results. So the bigger our sample, the more we're going to trust it. And that's all that you really need to know about this. Whichever one has the bigger sample size is going to take the greater weight. Okay, let me pause now and I will